Okay, in this lesson we're going to take a look at reflections on the coordinate plane. The first thing I just want to really quickly review is the notation we're going to be using. For rotations we used an uppercase R. For reflections we're going to use a lowercase r. And the subscript is going to be the line we're going to reflect over. So in this particular case we're going to be reflecting over the y-axis. So you can see I'm using a lowercase r and a subscript of y-axis. We're actually going to look at 4 different line reflections in this lesson, but first we're going to look at y-axis. So I have a triangle here ABC, and what I want to do is I want to reflect it or flip it over the y-axis, and we don't need anything fancy to do that. Most of you should be able to do that no problem. A is going to come right over here as A prime, and that's going to go to point 25. B, looking like it's going to be right about here at 4, 3. That's going to be B prime. And C jumps right over that line to be 1, 2. And I connect that triangle just like that. And you can visually see a nice reflection over that vertical y-axis. Now there's a couple things that I want to just point out with before we head to our rule. I want to pay close attention to this blue line here. This blue line is connecting corresponding points. I can draw that line between B and B prime. I can draw the line between A and A prime as long as I'm connecting 2 corresponding points. Very, very important of how that line relates to the line of reflection. Okay, the first thing that we want to point out is that the line of reflection here bisects that line. So I can mark that by doing that. So in other words, A is 2 units to the y-axis and A prime is 2 units to the y-axis. The other important thing to note is that it is perpendicular, or these 2 lines are perpendicular. So the line of reflection is perpendicular to the line that connects the corresponding points. 2 very important things that we'll touch on definitely in class. But more importantly right now, I want to take a look at what happened to these points so we can come up with a general rule. And to do that, we'll jot down any point xy. And if I reflect over the y-axis, what has happened to the point? Well, you should have noticed that the x-coordinate has changed. It went from -4 to +4. In this case, it went from -2 to +2. So actually that x-coordinate was negated. In this case, we negated a negative, which gave us a positive, but it was negated. So there's our general rule for a reflection in the y-axis. In this slide, I want to reflect over the x-axis. The notation that we would use here is again lowercase r and a subscript of the x-axis. This one again you can do pretty much on your own just visually. A is going to jump right over, so we're going this way across the x-axis. A is going to come here to A prime, and that's going to be a 1, -1. B is going to jump across to here, so this would be B prime at 2, -3. And C prime is going to jump to here, which would be 5, -2. And I can complete my triangle, and there you have a reflection in the x-axis. Okay. Really quickly, just to comment on what I was talking about before, again, if I connect corresponding points, that blue line, just notice the relationship between the blue line and the x-axis right here. Notice that that blue line is getting bisected, and it's also perpendicular. Again, we'll touch more on that in class. For this, we'll do a general rule for a reflection in the x-axis. We have any point xy, and if I reflect in the x-axis, it looks like, if I take a look at some of the points here, it looks like A was 1, 1, became 1, -1. Looks like the y-coordinate got negated. So we can say that our general rule would become x -y. Okay? Okay, we're going to do 2 more line reflections, and actually we're going to separate them. So in this slide, we are only going to do this line y equals x right here. Okay, now what is y equals x? Now if you recall, y equals mx plus b, the equation of a line. In this equation, y equals x, if you'll notice, there is no y-intercept, so the y-intercept is 0, and the slope is 1. So we have a line that has a slope of 1, up 1 over 1, up 1 over 1, and I can make all those dots and a y-intercept of 0. Now if I draw that line, it's essentially this diagonal line that goes right through the origin. Now what we want to do is we want to take, so this is y equals x. So we want to flip this triangle over here. Okay. Again, we're going to use that concept of that blue line. Remember, the blue line that connected corresponding points was equidistant, or the same distance from the line of reflection, and perpendicular to it. So I can draw that. Okay. And I'm going to go to the same distance away, again being perpendicular to it. This would bring me to my new point C prime, which is 3, 1. I can do that with A as well. I'm going to draw that line perpendicular to the line of reflection. You see that right there. And go the same distance across on the other side, and that's going to bring me to A prime, which is 1, negative 1. I can do the same thing with B. I'm going 2 diagonal units, and I'm going to go 2 diagonal units this way, and that's going to bring me to 3, negative 1. Okay, I can connect that, and there I have a reflected triangle over the line y equals x. And I use that concept of this blue line being perpendicular and equidistant from the corresponding points. So now we'll take a look at a general rule of what happens when you reflect over y equals x. If we take a close look at the points, let's just take B for example. Negative 1, 3 became 3, negative 1. Hopefully you'll see that in a reflection over y equals x, it looks as though the coordinates have been flipped. So xy becomes yx. This slide has the same triangle, but instead of doing y equals x, we're going to take a look at y equals negative x. Hopefully you might notice that same y-intercept of 0, but instead of a positive 1 slope, it has a negative 1 slope. So that's going to be going in this direction, like so. So that's going to be a diagonal line that goes something like that. So we're going to use the same concept to reflect our original ABC over this line y equals negative x. Alright, if we use our strategy of corresponding points, we can use, well, this one's really easy. A is on the line of reflection, so A is staying where it is. B is going to come right over here. There's going to be B prime at negative 3, negative 1. I'm sorry. That's negative 3, 1. C is going to follow right on this line all the way across to there. And that's going to look like negative 3, negative 1. Connect that, and there you have your triangle ABC reflected over the line y equals negative x to give you A prime, B prime, C prime. So this also is A prime at negative 1, 1. Alright, check out a general rule for that. So any point xy reflected over the line y equals negative x. And if we take a close look at the points, it looks like they have flipped. The x and y coordinates have flipped, but they also have been negated. So we are going to call that a negative x, negative y. I'm sorry, negative y, negative x. So in this slide, we're just going to summarize the 4 reflections that we just did. For reflection over the y-axis, we negated the x-coordinate, and that's what our general rule looked like. For a reflection over the x-axis, we negated the y-coordinate. Okay. Then we had y equals x, where we flipped the coordinates. xy became yx. And we had a y equals negative x, where they needed to be flipped, but also negated as well. Again, these are very important to memorize and know, so that any point, that you can take any point and reflect it over any one of these 4 lines. All right, and that concludes our reflections lesson.